Alright, guys. Hey, it is May 20th, and we are talking about the rock cycle. Okay? So, we're going to look at this sheet, this fact sheet. Lots of different facts and cool stuff about rocks. And then we're going to answer a worksheet. Okay? So, first, let's take a look at these. Okay? Alright? The outmost layer of the Earth, called the crust, is made from rocks. All of the mountains, ocean floors, volcanoes, valleys, and cliffs on our planet are made from rocks. But what exactly are rocks? How do they form, and what are the different types? How can rocks change over time? We have looked at the rock cycle before. Hopefully this helps bring it all together for us. Okay, let's look at these pictures. From left to right, we have Red Rock Canyon, Nevada. Okay, basalt columns in the Isle of Mull, folding in Ness. Okay, and then we have lava from Kilauea, Hawaii. Pretty cool, all different rocks. Okay, the rock cycle. No rock stays the same forever. Over thousands and millions of years, rocks are broken down, moved around, and deposited in different places, just like water. Rocks can be compacted together and pushed deep into the earth, where they are melted or deformed by intense heat and pressure, only to be uplifted again to the surface. All of these processes combine to make the rock cycle. Guys, look at all these words here, okay, and these arrows. I think this is going to come in handy, because I think what we're going to be doing is basically filling these in. So take a good look here. All right. What are rocks? Rocks are made from a mixture of different minerals. These are solid chemical compounds that occur naturally on Earth. Some rocks are made from interlocking mineral crystals that fit tightly together, whereas others are made up from broken fragments or grains of older rocks and minerals which have been cemented together. Okay, here's a rock with interlocking crystals. You can see how shiny it is. And then sandstone, this is a rock made from little fragments of older rocks. Depending on the way a rock is formed, it will belong to one of these groups: igneous, sedimentary, or metamorphic. Okay, igneous, sedimentary, metamorphic. These are the three main types. Okay, you'll see that they're in blue here in our little diagram: igneous, sedimentary, and metamorphic. All right. Okay, let's look at these: igneous, sedimentary, and metamorphic. Rocks on the Earth's surface are gradually broken down into smaller pieces by water, ice, wind, plants, and animals, known as weathering. Okay, these broken up pieces are called sediment. Okay, that's why it's sedimentary, and are transported away or eroded by rivers, glaciers, and wind. Sediments often collect at the bottom of lakes and oceans. Over time, they are squashed and compacted together to become a sedimentary rock, such as sandstone, limestone, or mudstone. Sedimentary rocks are laid down in layers. They can contain fossils from animals and plants that became trapped in the sediment before it became a rock. Beds of sandstone, mudstone, and limestone in the Grand Canyon. Okay? Ammonite fossil in a sedimentary rock. Sedimentary rock are made up of grains, which can be rounded or angular. Under the microscope, we can sometimes see gaps between the different grains. These gaps are called pores. If the pores connect together, water, air, or oil can flow through the rock, and if the rock is called permeable. If a permeable rock is put in water, you will see bubbles coming out as the water pushes the air out. So you can see, if you looked at it under a microscope, there's little pockets of air in between these rocks, and water and oil and things can go in there. Okay? That's why if you have a granite countertop and you set a glass of water down there for too long, you'll see a wet spot, and it'll actually have soaked into the granite a little bit. It'll dry and it'll come back out, okay? But granite is a rock that can be permeable, all right? And this one is non-permeable. You see there's not many air pockets there. All right, let's look at igneous rocks, okay? When rocks push deep enough down to the earth, they can melt to form molten rock. Below the surface of the earth, molten rock is called magma, but when it erupts above the ground, usually through volcanoes, it's called lava. Igneous rocks form when either magma or lava cooks down and turns into liquid to solid. When this happens, igneous rocks form crystals and are called crystallized. Lava cools down very quickly because the surface of the earth is cold. This means that igneous rock formed from cooling lava, such as basalt, only have time to grow tiny crystals. Often gas bubbles get trapped in these rocks, too. Obsidian, or volcanic glass, cools so quickly that you cannot see any crystals at all. Magma deep within the earth takes thousands of years to crystallize because it is much hotter below the surface. Crystals have more time to grow, so they grow larger. If you look closely at an igneous rock that has formed deep within the earth, for example granite or gabbro, you will be able to see the difference colored mineral crystals. Okay, and granite's the one we were talking about that also has these spaces, just like sedimentary rock. Okay, all right, and then the last one is metamorphic. Metamorphic rocks are rocks that have been changed over time. When rocks are pushed deep down into the earth, grains and minerals can become stretched, squashed, and slightly melted from the extreme pressure and heat. This is called metamorphism, and it causes new metamorphic rocks with different textures and or minerals to form. You see all these different textures here, all these different lines on the rock. Okay, metamorphic rocks are crystalline like igneous rocks. However, the minerals in the metamorphic rock tend to line up to form layers, like in this gneiss from northwest Scotland. See how there's layers here. Okay, the metamorphic rock you end up with depends on the type of rock you start with and the amount of heat and pressure the rock is in. Here are a few examples of metamorphism that can occur. You take granite and gneiss. Okay, granite turns into gneiss. Mudstone turns into schist, shale turns into slate, limestone turns into marble, sandstone into quartzite, and basalt into echolite. Okay, so it's kind of like their Pokemon evolution. Okay, and they need heat and pressure in order to turn into that. Okay, so metamorphic are squashed down with heat and pressure to form a whole new rock. Sedimentary, they're just pushed together like a sandwich. Okay, all right. In igneous, they are actually melted down together. All right, so now that we've done that, let's take a look at our rock cycle worksheet. Okay, all right. So for this one, I'm going to use my worksheet here. Okay, I can see that this top one here is weathering next to the clouds. It makes sense. That looks like weather. So is weather one of my, yep, weather right here. So I can get rid of weathering, and that's going to go right there next to my cloud. Okay, all right, I look at my sheet. Next is erosion and transport. Okay, is erosion, oh, there it is, erosion and transport. Okay, erosion and transport. Okay, and that means that the weather is making that rock, it's pulling the rock up. We saw how water can move rock, and see how it's making this little river down here, and it's eroding and it's transporting the rock down the river. Okay, all right, next we have deposition of sediment. This is when the stuff travels through the river and then it stops, so it's deposited. Okay, let's see, is that one? Deposition of sediments. Yep. If you deposit something, you're leaving it there. Deposition of sediment. If you deposit money in the bank, you're leaving it there. Okay, so this is when the rock gets left there from the water. All right, now let's take a look here. We got a big process here. This next arrow goes to burial and compaction. This is when the rocks on the top start to get buried and they start to get compacted. Okay, so let's see, do we have it over here? Burial and compaction. Yep. Burial and compaction. Very good. Okay, and I also saw that when some of this rock gets lifted back up, it's called uplift. It doesn't always have to be a volcano for it to get uplifted. Sometimes just the way the rocks shift and move, some rocks can poke out of the ground. Oh, sorry. All right, and then this next one is our first big one, and that is sedimentary rock. Okay, so we can get rid of uplift, and now sedimentary rock. Okay, remember, this is the one that's packed down like a sandwich, like a panini press. Okay, sedimentary rock. You can see this layer of rock right here has just kind of been squished down. That's sedimentary rock. Okay. All right, now when some of that changes, okay, it undergoes metamorphosis. Okay, and yep, metamorphosis right here, just like a butterfly. Okay, think about this is what the Pokemon, this is when it's evolving, it's changing. Okay, metamor. And if you need a little help spelling, it's right up here. Metamorphosis. Okay, phosis. All right, and then after sedimentary evolves, it turns into metamorphic rock. Okay. All right, makes sense, right? It goes metamorphosis, so it's metamorphic rock. So now we have metamorphic rock. Good. All right, after metamorphic rock, okay, some of that rock can get really hot and it melts. Okay, here's melting, and that is the next one here in our arrow. Melting. Okay. All right. And then the last ones we have is it crystallizes. Okay, remember we talked about how it gets those crystals and it turns into igneous rock. So we should have a couple left. All right. And we should have, yep, the only two left are igneous and crystallization of magma. So crystallization happens first. Of magma. And then that turns into igneous rock. So you can see there's a whole crazy cycle here. And it can go from sedimentary to metamorphic to igneous. And guess what? After igneous, that weathering's going to wear down that cooled down lava. And it's going to turn back into sedimentary. That's why it's a cycle, is because they keep turning into each other. Okay, they never really end. Okay, so let's look here. Use the space below to draw the stages of which sedimentary rock might form. So weathering, okay, I'm going to draw, I know this is when rain, ice, and wind break up rocks into fragments. So I'll draw a little wind. Okay, maybe some drops of water. Okay, and maybe I'll draw a big rock right there. And maybe some little rocks coming off of that. Okay. All right, so you see I got some little rocks coming off because of wind and water. All right, erosion. All right, this is when rivers, glaciers, and wind transport the sediment away. All right, so maybe I'll have a nice little river right here. Okay, and in there I'll have a couple of my rocks. Okay, pew, 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 pew. Little speed signs on there coming through. So we have a river here, and it's transporting my rocks. Okay, that is erosion. Deposition, sediments that are laid down in layers in a sea or lake. Okay, all right. So maybe here I'll have a nice beach. Okay, because we know that those rocks get deposited on the beach, right? That's why it brings new sand and seashells, right? The water does. Okay, so deposition is when it kind of leaves it there on the beach. All right, burial and compaction. This is when that same beach layer is now covered by more beach layers. And it has other old beach layers under it. Okay, different kind of rocks in each of them, so they can be different colors. Okay, all right, burial and compaction. All right, and it keeps getting compacted, so it's pushed down. See that? So I drew my layers and I drew forces going down. And then sedimentary rock, okay? All right, sediments are cemented into a rock. So here I get my final rock, but it's going to look like my compacted rock. So you see here, this is a whole beach, right? And it all looks like these different layers. Well, what happens is little pieces of that get squished together, and then they turn into rocks, which have the same lines. So if you see lines in a rock that looks like it has layers, like it was a sandwich that was panini pressed, Okay, that's a sedimentary rock. Alrighty. Okay, let's look at our igneous rocks right here. Granite and basalt are two types of igneous rock. Granite has large crystals where basalt has tiny crystals. See these nice big large crystals and tiny crystals. Label a diagram to show where each rock forms. Okay. Now remember, it has to do with how slow they cool. Okay. If it slowly cools, it has real nice big crystals. If it cools very fast, then it's going to have small crystals. Okay, because it's how long it has time to grow the crystals. All right, it's colder outside, right? It's like a little, draw a little it's Mr. Alt's best snowflake. Okay, so it's colder outside, so whichever one has small crystals is going to be outside. Okay, granite has large crystals, so that means granite would cool inside the earth. It's hotter down here. Okay, so it's going to take, in this little pocket under the earth, it's going to take longer to cool down, and it's going to grow nice big crystals. Okay, whereas this guy, all right, has tiny crystals, so basalt. Okay, all right, now why do you think granite usually has larger crystals than basalt? Okay, think about temperature. Okay, so I think it has larger crystals than basalt because it cools inside the earth where it is hotter. Cools down slower inside the earth because it is hotter there. Dun dun. And Mr. Alt forgot his subject. It cools down. All right. Now, last one, metamorphic rocks. How can sedimentary rock become a metamorphic rock? Metamorphosis. Okay. All right, let's see. Let's see anything about here. How can sedimentary rock become metamorphic rock? I know it has two things. It needs to be squashed and slightly melted from extreme pressure and heat. That's it. Haha. Squashed and slightly melted. Okay. Squashed. It must become squashed. I like that word, squashed. And slightly melted from extreme pressure and heat. Boom. All right, and where did I find that, guys? I found it right here. Squashed and slightly melted from the extreme pressure and heat. That's how rocks, okay? When rocks turn into metamorphic rock. All right, guys, hopefully this helped. Hopefully it's fun drawing some pictures, learning a little bit about the rock cycle, finishing it up. Have a great day. Hey, guys, it's Mr. Alt. Did you enjoy that video? You finished your work for the day and wish there was just something else you could do? Our Microsoft Teams page, available on your computer or on your phone or tablet. And come to the left and click Enrichment Opportunities, and there's lots of extra things here for acting, art, science, history. You'll see our Jeopardy games. Lots of fun stuff to do if you finished your work for the day. It's extra, so it's not mandatory, but it is there for you. Okay? Enrichment Opportunities under Mr. Alt's class. Have a good one!